Nobody cares. Okay, here we go. So, the question was asked. What just happened there? The question was asked by Carly yesterday. What is going on right here?
Oh, we can't do it.
There it goes. All right, Carly asked yesterday whether all these descriptions. Why is this thing messing up?
I don't think it likes you today.
It's definitely not wanting me to do my job. Okay, maybe it's gonna work. Carly asked, would all these descriptions be on the quiz? No, they're not. Sorry. I looked yesterday. Maybe I could pencil them in before I make copies. But basically, you just have to be able to read, and that's probably the trick. You have to read these problems, and it's a job of you to decide how they're going to work. So it's not that hard. Y'all can do it. I promise. So here we go. Number one, a six-sided number cube is rolled, and then a card is drawn from the standard deck. Find the total number of outcomes. See, you're not finding the probability of something. You're finding the total number of outcomes. Basically, if you were finding probability, you'd be finding the bottom number right now, right? So this was what we called the fundamental counting principle. How many things are going on here? Yeah, you got a six-sided number cube. How many possibilities for that? 6 for sure, right? But then you also have the standard deck of cards that have how many cards in it? 52. So there's 6 different possibilities with the number cube. There's 52 different possibilities for this deck of cards. So in all, there's 6 times 52 possibilities. 6 times 52 total number of outcomes. So 6 times 52 is 312. There's 312 different possibilities. Does that make sense? Okay, keep moving. Number 2, a science quiz has 8 multiple choice questions with 5 choices for each. Find the total number of ways to answer the question. So, again, we had a problem that was kind of like this with true false. Do you guys remember? So, try to imagine there's 8 different problems, right? Let's see, 1, 2, 3, 4, 5, 6, 7, 8. 8 different problems. Well, how many ways is there to solve every problem? There's 5. So there's 5 here, 5 here, 5 here, 5 here. And if I want to figure out the total number of ways, well, every one of those problems could have been answered 5 different ways. So I'm literally taking 5 and multiplying it by itself 8 times. So you could have done 5 to the 8th power. Or you could have done 5 times 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 5. Either one's going to give you the correct answer, and that is there would be 390,625 different ways someone could answer this quiz. Okay? Questions? Number 3, the golf club can send a team of 4 students to the next golf tournament. If there are 15 students in the club, how many different teams of 4 can be selected? All right, so we have 15 people. We're selecting 4. Well, anytime you have a problem like that, okay, 15 people selecting 4, you know it's either going to be a permutation or a combination. So the only question you have to answer is order important here? Are you organizing these players? Does the question say you're organizing the players into positions? No, it's just saying, hey, what's the different number of outcomes that you could pick 15 players in 4 ways? So you're using a combination. So you're going to do 15. Always put the big number first. Then you're going to do math. Scroll over to probability. You're going to do the C, the NCR, and then you're going to put that you're organizing these into 4 different players. Not really organizing. You're just a possibility of 4 different players. So it's 15 with a combination of 4. Did y'all type it in? What'd you get?
1,365.
Yes, 1,365. But if you look at the very next problem, notice the difference, hopefully. There are 18 skaters competing in a competition. How many ways can they win gold, silver, bronze? See, it's 18 for 3, but what do you know about those 3? There's order. It does matter. If I win gold, I can't win silver. If I win silver, I can't win bronze. It matters. So we have to use 18 with a permutation of 3. Okay? So 18, always put your big number first. Math, probability. This time you pick NPR, and then of course you organize it into 3 places, and you push enter, and you get 4,896. So far I think it wasn't so bad, right? But I think number 5 tricked some people. So let me talk about this one. Number 5 says, what's the total number of different 10-letter arrangements can be formed using the letters in the word suspicious? So we had this a couple of different ways. One, we said it's kind of like the hat problem I told you. 9 hats on a shelf. It's 9 factorial, right? So right off the bat, I know factorial is involved because I got these letters. It's basically like I cut them out, and then I want to know how many different ways could I put them in order. So that's 10 factorial. However, do you notice anything about this particular problem that we talked about in our notes? There are some repeated letters. Look, S is 1, 2, 3 times. Is that going to affect the outcomes? For sure. So to take care of that S that got repeated 3 times, we have to divide by 3 factorial. Because S is repeated 3 times, it would affect certain places where S could be, because if I've cut these pieces of paper out, there's still 3 S's, right? So it wouldn't have mattered which S ended up in the first place. It changes probability. You understand? But was that the only thing that was repeated? No, you also had U. How many times was U repeated? So that's 2 factorial. Was that it? No, we also had I repeated twice. So we had to take care of that with 2 factorial. So this one is a factorial problem. So 10 factorial, but we had to divide by 3 factorial, 2 factorial, 2 factorial, because those letters were repeated. Think y'all can remember that? Now, if no letters got repeated, would you have had to do that? No. But they were. We had to. So if you go type all that in, alpha y equal, number 1, put 10 math probability, number 4, factorial, over 3 factorial, 2 factorial, 2 factorial. Your answer gives you 151,200. Okay? All right, moving right along. Now we move into probability. And yes, I know that it says probability, and that helps. And maybe it's not on the quiz like that, but you got to look at what it says. It tells you what is the probability of drawing a jack or a red card from a standard deck. It's telling you probability, okay? So I am pulling out a card from a standard deck of playing cards. Guys, how many cards are on a standard deck? So I'm pulling a card out of a deck. And I want to know what's the probability that it's a jack or it's red. Now, what do you know about jacks? Y'all know anything about jacks? What do y'all know about jacks? There's 4 of them. There's 1 jack of every suit. There's 4 suits. So there's 4 jacks. Now, 4 jacks. How many red cards are there? There's diamonds and hearts, right? 2 suits, and every suit has 13 cards. So there's 13 and 13, which is 26. So there's 4 jacks. Okay, there's 26 red cards. However, what do you know about the jacks? 2 of them are red, right? So I'm either going to count them in this category of the jacks, or I'm going to count them in this category of all the reds. You can't count them in both because then you've got doubles. Okay? So here's what I did. I said I had 4 jacks, I had 26 red, but 2 of those jacks are red. So 26 plus 2 is 28. So I have 28 out of 52. 28 out of 52. Now that reduces to 7 over 13. That's pretty tricky though, right? Pretty tricky. But y'all can do it. All right, moving along. A bag contains 40 slips of papers numbered 1 through 40. Okay, so that tells you there's 40 of them. If one is randomly chosen, what's the probability of not choosing a multiple of 3? All right, so what's my bottom number? 40, right? There's 40 total slips of paper. So I know that my total number of outcomes is 40.
Teachers, pardon the interruption. This is a reminder that the bells will be off today due to WIDA testing. And the following students need to report to room 141 for WIDA testing. Raymond Arredondo, Luz Galvez Salazar, Valeria Galvez, Abrejo, Kennedy, Petsavi Martinez, Hervin Perez, and Ashita Tarai. Those students need to report to room 141 for testing. Thank you.
All right. Sorry about that. Y'all good to go? All right. So, multiples of 3. Okay? It just means if you multiply 3 by something, it gives me these values. So 3 times 1 is my first multiple of 3, right? Because 3 times 0 is 0, and that's not in these slips. So we got 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. That's 10, right? 33, 36, 39. That's 13 out of 40. That's how many we have that are multiples of 3, correct? Is that what this question asks? No, it says how many are not multiples of 3. This is a complement. So what do we subtract that from? 1. Okay? See, this is what I was talking about when we talked about complements of probability. Sometimes it's easier to find what it is and then just subtract it from 1. Remember 1 being 100%. So we're doing 100% minus 13 over 40. So 1 minus 13 over 40 is 27 over 40. And that's my answer. It won't reduce. Again, feel free to type in alpha y equals number 1, and it will do all the reducing for you. All right? Number 8. A coin is tossed 2 times. What do we say about multiple events? Multiply events. Okay? So 2 times. Then a month of the year is randomly selected. All right, so we got another one. So we got 3 things going on here. A coin's tossed 2 times. A month of the year is randomly selected. What's the probability of getting tails each time? Okay, pause. Let's do that one first. The first time I flip that coin, what's the probability I get a tail? Or 1 out of 2, right? 1 out of 2. Okay, the second time I flip it, did it change? Of course not. It's just a coin. Still a 1 out of 2 chance. And then, of course, last, it says, and a month that starts with the letter J. How many start with the letter J? 3, January, June, and July. So that's 3 out of 12. So the probability of a coin being tossed twice, getting tails both times, and a month of the year being chosen and it being the letter J is 1/2 times 1/2 times 3/12, which is 1/16. Does that make sense? Okay, number 9. A bookshelf contains 9 mysteries, 7 biographies, and 4 science fiction books. A book is randomly selected, not replaced, then another is selected. How many am I choosing? Multiple events? Multiply events. So let's see what it asks first. Find the probability of selecting a biography, then a mystery. So first of all, guys, what's my favorable outcome for selecting a biography? How many biographies were there? 7. What's my total number of outcomes, though? Why'd you get 20? Yes, 9 plus 7, 16, plus 4 is 20 total books on the shelf, right? Now, key word, it's not replaced. You read this book, you put it off to the side, you go back to this bookshelf. Now how many books are there? 19. And how many of them are then a mystery? So it's 7 out of 20 times 9 out of 19. Again, I would encourage you guys to use your alpha y equals number 1. And then, of course, let those multiply and reduce. You should have gotten a 63 out of 380 chance. Okay? Questions? I think we talked about 10 yesterday, didn't we? But let me talk about it again. A shape is randomly selected from a following quadrilaterals, 4-sided figures. That's what quadrilateral means. Parallelogram, rhombus, rectangle, square, and trapezoid. We have 2 minutes? That's got to be a joke. Okay. Well, let me go faster then. You know what? Let me just say this. If time expires, I'm just going to keep talking to finish the review. It's just the only thing I can do. Anyways, it says, what's the probability that it has 4 right angles given that it has 4 congruent sides? That's the given that. Remember, what am I zooming in on? What's my first zoom? We have these 5 quadrilaterals. What's my first zoom? 4 congruent sides. Out of those 5 quadrilaterals, which ones by definition have 4 congruent sides? You may remember? Not a parallelogram. By definition, parallelogram says opposite sides are parallel. Square, definitely. There's one more. A rhombus. Rhombus is like a sideways square, if you will. It has 4 congruent sides. So there's 2. We zoomed in on 2 of them. Now we zoom in again. What's the probability that out of those 2, rhombus and square, that it has 4 right angles? Only 1. Only a square. Okay, only a square. Rhombus is kind of like a parallelogram that has 4 congruent sides. Okay? Questions about that? All right, let's go to the back. And again, if I don't finish, let me just say this. Your quiz tomorrow has 16 questions on it. 16 questions. That includes like your A's and B's and stuff like that. Because there's a couple of those. But anyways, there are some that are multiple choice. There are some that are not multiple choice. But the majority of it is multiple choice. Okay? So that helps, in my opinion, a little bit. All right, here we go. Like I said, if class ends and you guys have to leave, if y'all don't mind, just stay as quiet as possible. I'm going to finish the video as the other group walks in, and that way people can just watch videos. Okay, here we go. A bag contains 25 red chips, 18 blue chips, and 29 yellow chips. How many chips we got, y'all? We got 72 chips. Okay, it's good to get that out of the way. 72 chips. Now, it says that a chip is selected, replaced, then another chip is chosen, okay? So replace tells me it goes back in, right? So what's the probability of blue, then red? Okay, so let's start with blue, but we know that we're also multiplying, okay? So how many blue ones were there? There were 18 out of those total 72 chips. You grabbed a blue one. You did good. You put it back in. How many chips are still there? Still 72 chips. But this time, what was the probability you grabbed a red one? So it's 18 over 72 times 25 over 72, which ended up being 25 over 288. Y'all good with that? Okay, let's go to the next one. How about a probability of yellow and then blue? So again, multiple events, multiply events. We got 72 chips. How many of them were yellow? 29. You did it. You got a yellow chip. You put it back in. You reach back to find another one. What's the probability that it's blue? 18 out of 72. So you multiply all that together, and this one is 29 out of 288. Okay? Questions about that? Next one, a box contains 3 cheese slices, 7 pepperoni slices, and 5 supreme. How many slices we got? We got 15 slices. Mark randomly chooses a slice, eats it, and then chooses another. Guys, what happens when you eat it? It's gone. You can't replace it. It's gone. So if I can't replace it, then of course it's going to change my probability. Whoops. I didn't mean to do that. Sorry about that. So it's going to change my probability. So here we go. What was the probability that I picked the cheese? 3 out of 15. You did it. Mark grabbed a cheese piece, ate it. It's gone. How many pieces of pizza are left? And how many of those are supreme? So it's 3 out of 15 times 5 out of 14, which equals 1 out of 14. How about 2 pepperonis? Well, that's 2 of them. Multiple events, multiply events. I reached into this box and I grab a pepperoni. What was my probability of that? 7 out of 15. Eat it. It's gone. Reach back in the box. How many pieces of pizza are there? And how many of those are pepperoni? Only 6. So it's 7 out of 15 times 6 out of 14, which is 1 out of 5. Y'all have any questions before you leave? I will finish this. If you don't have a chance to watch it, when you come in tomorrow, I will make sure and stay in here. I won't go up there. If you have questions tomorrow morning when you come in, I'll answer them quickly, okay? But let me finish this while you guys are leaving. And I'll see y'all tomorrow. It'll be weird, but y'all are, is it time?
29.
Okay. Remember, there's no bell. So if y'all don't mind, as quiet as you can, walk out, and I'll see y'all tomorrow. Okay. Of the 318 sophomores, 140 are taking Algebra 2, and 102 are taking Chemistry. So there's my 2 things. I got my 2 circles, and my 2 circles include both Algebra 2 and Chemistry. All right? It says 26 are taking both of those. So I'm going to put 26 right smack dab in the middle. And then I'm going to do a little bit of math. If 150 took out, or 140 took Algebra 2, but 26 also of that 140 took Chemistry, then 140 minus 26, or 114, took Algebra 2. 102 took Chemistry, but of that, 26 also took Algebra 2, so only 76 took Chemistry only. So here's the probability. If a sophomore is chosen at random, find the probability that they are taking Algebra 2, so the probability that they're taking Algebra 2, given that they are taking Chemistry. I'm still recording. I'll explain in a minute. So our zoom in, what we're going into first is we're focused on those that are taking chemistry. Okay? So the people taking chemistry is this big circle right here. So we talked about those at the beginning. That's 102. So my bottom number is 102. Now, out of those that are taking chemistry, so look, we're only focused on those. Hey, hush. Be quiet. I'm seriously making a recording right now. All right. So out of those people who are taking chemistry, how many are also taking algebra 2? Well, that's 26. So we got 26 out of 102, which reduces to 13 out of 51. What a weirdo. Okay. So last two problems, I'll explain why I'm doing this in a minute, guys. I'm sorry. It's really weird. The last two of these are conditional probability, where we're using these charts to the left. So let's start with 16. It says, what's the probability that a male owns an Android? See, there's no condition here, meaning there's no zoom in. So my zoom in is the whole set of data. So if you calculate all this, 34 plus 30 plus 19 plus 42 is 125 people, okay? So this problem, my zoom in is the whole data, 125 people. Now, how many are males that own Androids? Well, males that own Androids are right here. 34 really, really intelligent people because they own Androids. So 34 out of 125 will not reduce, so we leave it be. Okay, that's it. Moving on, we've got the next one says the probability that they have Apple given that they're male. See, there's my zoom in. I'm zooming in on those that are male. Right here, I'm zooming in on 64 people. Now, of those 64 people, how many choose Apple? 30. 30 weirdos. So 30 out of 64 will reduce to 15 out of 32 strange human beings. All right, moving on. The next one, look at it. It says probability of female given that they're Android. Well, Android is my zoom in. Okay, I'm zooming in on those only who like Android, smart people in the world. So that's 34 plus 19, which is 53. 53 is my bottom number. Now, of those people I've highlighted who are Android users, how many are female? Well, that's 19. So 19 out of 53. It won't reduce. That one's done. Now, 17, we got 5 of them. Please excuse me, you guys. It's weird. So look at A. We're finding the probability of a U.S. bronze medal. See, it doesn't zoom in on anybody. It's just focused on people who are U.S. bronze medals. So my bottom number is everybody. So if I add all these up, that's a total of 191 people. So 191 is my bottom number. Now, of everyone, how many are U.S. bronze medal holders? That's 29 out of 191. Okay, so that's done. Let's do the next one. What's the probability of a gold or silver medal? So again, that's out of everyone. That's out of 191 people. So how many won gold? All of these. How many won silver? All of these. So we add all of those categories up. 46 plus 38 plus 28 plus 28 is a total of 140 out of 191. All right, last two. Oh, sorry, 3. What's the probability that they got silver given that they're from China? So again, there's my focus. It zooms in on those that are from China. That's 38 plus 28 plus 22. 38 plus 28 plus 22 is 88 people. Now, of that group I've zoomed in on, how many won silver? 28. That will reduce down to 7 out of 22. Okay, next. You've got the probability that they're U.S. given that they won gold. There's my zoom. I'm zooming in on gold. I'm zooming in on this category right there, which is 46 plus 38, 84 people. Now, of that group, how many are U.S.? 46. So 46 over 84 will reduce to 23 over 42. And the last one, let me erase this. What am I zooming in on? Given that not silver. Not silver means all of these and all of those. So you can add all those up. 46 plus 38 plus 29 plus 22 is 135 people did not win silver. So from that group, from the highlighted ones, who's from China? Well, that's 38 plus 22 people. That's 60 people out of 135 total, which reduces down to 4/9. So there it is. I've gone over the entire review, 2 classes, because our time is cut short today. So remember, tomorrow you have a quiz, 16 questions, and I hope that you prepare and do well.